In this video, we are going to discuss two-dimensional motion, which is a continuation of our discussion on linear motion. So if you don't know your way around linear motion, so I suggest that you watch the previous video on linear motion. The link is going to be displayed at the start of this video. Now to two-dimensional motion. So what is two-dimensional motion and what does it entail? A two-dimensional motion is the motion that occurs both in x-axis and y-axis of the Cartesian plane. Unlike linear motion, a linear motion occurs in just one axis of the Cartesian plane. So a linear motion can be a motion of an object thrown vertically upward. So when an object is thrown vertically upward, that means the motion is just on y-axis, and that is a linear motion. Or if you roll an object on a smooth horizontal floor, that is a motion that occurs on the x-axis. So those type of motion are called one-dimensional motion or just linear motion. But a two-dimensional motion occurs on both axes. That is, it has parameter on the y-axis and also has parameters on the x-axis. Take for example, if you throw a javelin at a particular angle, so if you project a javelin this way at a particular angle to the horizontal, the javelin is going to move in this form. So this kind of motion is called two-dimensional motion because it has parameters on both x-axis and y-axis. So it's not totally, so the motion is not totally on x-axis and it's not totally on y-axis. It is for both. So it is called two-dimensional motion. Now there are some facts that you should know about two-dimensional motion. Now go ahead and tell you those facts. Number one, two-dimensional motion takes the shape. As you can see, the motion of javelin thrown at an angle that would describe it had the shape of parabola. The second thing you should know about two-dimensional motion is that it has two components, and those two components are independent of each other. So there is independence of the two components. That is, you take velocity as example. Velocity along the x component, which I will write as Vx, is independent on velocity of the y component, which I will write as Vy. So the motion of the two objects are independent of each other. Number three, you should know that when an object undergoes two-dimensional motion, which is commonly called projectile, the velocity along the horizontal component is constant. What we mean by that is that when an object undergoes two-dimensional motion, velocity along horizontal component is constant. So what it means is that if you start with an initial velocity of, let's say, 15 meters per second, you are going to end with a final velocity along the horizontal component of 15 meters per second. It means that Ux must equal to Vx. That is very important for you to know when you are dealing with two-dimensional motion. So when you are treating two-dimensional motion, these are the things that examiners look for in the topic. The first one is time to reach maximum height. So when you project an object, examiner might ask you to find the time to reach maximum height. And I will designate that with small letter t. Number two is time of flight. That is the time taken for the projectile to complete its motion. I will designate that with capital T. You might be required to look for the maximum height attained. So I'm going to designate that with h. You might ask to look for the range, which we'll talk about later. Then the last one that you might be asked to look for is maximum range. So note that there's a difference between range and maximum range. Now, how do we explain each of these parameters? The classical examples of two-dimensional motion that you might encounter in physics usually look this way. Number one, you can project an object from a certain height and the object returns to that certain height. So the shape of the parabola is going to look like this. So let's say you project the object with an initial velocity u, and it is projected at a certain angle to the horizontal. So this is one classical example of projectile motion that you can see. Then again, you can have an example of projectile motion that looks this way. An object projected from a certain height. The object can be projected with an angle which is going to look this way, and it returns to a particular height, or it can be projected horizontally, and then it's going to have this path. So these are the common examples of projectile motion that you can have on a test. These are the classical examples, and each of the paths takes the shape of a parabola. Now, the one I'm going to use to explain the 5 parameters that I've listed is this first one. When an object is projected at a particular angle and it returns to the point of truth. So I'll stick with this to explain each of the parameters. Now let's start with time of flight. As I said before, in two-dimensional motion, we have the components of our motion to be in two. That is, we can have the horizontal component and we can have the vertical component. And each of them, they are independent of each other. So if an object is projected with an initial velocity u at an angle of theta to the horizontal, it means that the velocity, that initial velocity, is going to look like this in component. So this is u, and then this u is going to have a vertical component, which I will call uy, and it's going to have an horizontal component, which I will call ux. So it acts horizontal component and vertical component. It then means that the components of the velocity along the y will be u sine theta, because this is opposite and the u itself is hypotenuse. And the component along the horizontal axis is going to be u cos theta. So now let's look at how we are going to calculate the time to reach maximum height, or how we are going to calculate the time taken for the object to attain maximum height. Understand that maximum height is the distance between the point of projection and where the object stops momentarily. Since I'm looking for time taken to reach maximum height, I can simply use v equals to u plus gt. Now, I'm dealing with vertical components, so I'm going to use vy, uy. The final velocity along the vertical component is equal to 0 because it's stopping momentarily. It has reached its maximum height. So vy is 0 meters per second. Now, we said that uy is u sine theta. So now we can plug this into each of our equation. That means we have 0 equals to u sine theta minus gt. I'm taking minus because this object is projected upward and is going against gravity. So if I add gt to both sides, it means gt equals to u sine theta. That means time to reach maximum height is going to be equal to u sine theta over g. So the formula we are going to use to calculate time to reach maximum height is u sine theta over g. Going to the second one, let's look for the time of flight. A projected motion is a motion under gravity. That means the acceleration of the object is constant. It means then that the time of flight is going to be equal to time for the object to go upward plus time for the object to come back to the point of truth. And since the acceleration is constant, time for it to reach maximum height and time for it to return to the point of truth will be equal to each other. Then it means that time of flight is equal to t plus t, which is 2t. Time to reach maximum height is u sine theta over g. We can substitute that in our equation and we have 2u sine theta over g. So this is the formula we are going to use to calculate time to reach maximum height. Now the third one is the maximum height attained. This maximum height is a vertical height. We are going to use vertical component of the velocity again. And we are going to use the equation v square equals to u square plus 2gs. So we are using the vertical component of the velocity. So this will be vy, this will be uy, and then this s, I'm going to call it h. So I will rewrite my equation as vy square equals uy square plus 2gh. Remember that we said that when an object is projected at maximum height, the final velocity is equal to 0. So remember that vy is equal to 0. That means we have 0 square equals uy is u sine theta. We said that at the beginning. So this will be u sine theta all square minus 2gh. You already know why I'm using negative. I'm taking downward as positive. So if I add 2gh to both sides, I'm going to get 2gh equal u sine theta square is u square sine square theta. Then if I divide both sides by 2g, maximum height attained will be u square sine squared theta over 2g. So this is the formula we are going to use to calculate maximum height attained. Now let's discuss range. What is range? The range in a projectile motion is the horizontal distance covered by the projectile. So if you throw an object this way and then it lands here, this horizontal distance, the distance between this point A and distance between this point B on the ground level is called range. So range is horizontal distance. Since range is horizontal distance, then we should use the horizontal component of the velocity. What we said about horizontal component of velocity is that it is constant. So ux is equal to vx, probably because it is not affected by gravity. Gravity acts downward, not horizontally. It then means that we have a constant velocity, and whenever we have a constant velocity, I'm going to pick ux since they're the same. It means that the constant velocity is the distance covered over the time taken. That means that the ideal formula for range is uxt. So you should have this somewhere. Range is equal to uxt, that is component in the velocity multiplied by the time taken to achieve that distance. Range then will be equal to ux is u cos theta, then t is 2u sine theta over g. Remember that. Then we can multiply. If we multiply this, we are going to have u square multiplied by 2 sine theta cos theta over g. And from trigonometry, we know that 2 sine theta cos theta is sine 2 theta. So range then will be equal to u square sine 2 theta over g. Now the last one we have is maximum range. An object covers the maximum horizontal distance when it is projected at an angle of 45 degrees. It then means that I can substitute this in my formula and say that maximum range is equal to u square sine 2 times 45, because theta is 45, to get maximum range, over g. 2 times 45 is 90, and sine 90 is 1. So it means that we have maximum range to equals to u square over g. So the formula for maximum range maximum, is u square over g. So now let's apply everything that we have learned so far in solving problem. We have a problem that says that a particle is projected at 60 degrees with a velocity of 15 meters per second. So angle of projection is equal to 60 degrees. Although it wasn't mentioned that it is projected at an angle of 60 degrees to the horizontal, we are going to assume that the angle of projection is to the horizontal. And then the velocity of projection is 15. So u is equal to 15 meters per second. We are given that g is 10 meters per second square. And the question is calculate the time of flight. So we are looking for time of flight. We are looking for big T. You can go ahead and use the equation of time of flight, which is 2u sine theta over g. That is going to give us 2 times 15 multiplied by sine 60 over g. So 2 times 15 is 30, times 60 is 0.866, and g is 10. So this is going to give us 3 times 0.866, and 3 times 0.866 is equal to 2.598 seconds, which is approximately 2.6 seconds. So the correct answer is going to be B. So if that is how you solve it, that is good. But for me, this is how I'm going to solve it. I know that this object was projected with a velocity of 15 meters per second. The angle of projection is 60 degrees. So what I'll do first is to find the y component, which is 15 sine 60, and find the x component, which, if I need it, 15 cos 60. So cos 60 is 0.5. 15 times 0.5 will be 7.5 meters per second. 15 sine 60 is 15 times 0.866 is equal to 12.99 meters per second. So I'm looking for time of flight. So I then use Vy equals to Uy minus Gt, because it's projected upward At maximum height, Vy will be 0. So I have 0 equals Uy is 12.99 minus 10t. So 10t equals 12.99 and t will be 1.299 seconds. But this is just time to reach maximum height, which means that time of flight is going to equal 2 times 1.299. We are going to get 2.598 seconds, which is approximated to 2.6 seconds, right? So we get the same answer. So this is how I solve it on the test, because it helped me to see the motion in each of its components. But if you use the formula, that is also okay. Now let's see another problem. You can pause the video and solve the question before we look at the solution together. So the question says that a football is kicked with a velocity of 25 meters per second at 45 degrees to the horizontal. So we have the initial velocity is 25 meters per second and the angle of projection is 45 degrees to the horizontal. Find the maximum height attained. So we are looking for age. All right. I'll use both methods. Let me use formula method, then solve it component by component. So if we are using the formula method, we are going to say that maximum height attained is u squared sine squared theta over 2g, which is equal to 25 squared multiplied by sine square 45 over 2 times 10. So this is going to give us 25 square is equal to 625. Now you need to know the meaning of sine square 45. So sine square 45 means you look for sine 45 first, then you square your result. So sine 45 is 0.707. So you square the result, then over 20. This becomes age equal 625. 0.707 square equals 0.4998, then over 20. So this is going to give us 625 times 0.4998 we give 312.406 divided 20. So at the end of the day, we are going to get 15.62, which is approximately 15.6 meters. So it means that the maximum height is 15.6 meters, and the correct option will be option C. Now, if I'm going to use my method, that is, do it component by component, I have that the initial velocity is 25, angle of projection is 45 degrees. So the first thing I will do is split it into components. So Uy equals to U sine theta, which is 25 times sine 45, and that is equal to 25 times 0.707. So this is equal to 17.675 meters per second. With the look of things, I will not need Ux, so I will not find Ux. Now I'm looking for maximum height. I can just simply say Vy square equals Uy square minus 2gh. All right, you understand why I'm using this. I've mentioned this earlier. So substituting each of the values in the parameters, this becomes 0 square equal 17.675 square minus 2 times 10 times h. And this is going to give us 0 square equals 17.675 square. This will give us 312.4056 minus 20h. So add 20h to both sides. We have 20h equals 312.4056. So if we divide all through by 20, we have 312.4056 divided 20, and that is going to give us 15.6 meters, which is what we got using the formula method. You can use any method that is convenient for you. Now, here's another problem. The question says that a shooter wants to fire a bullet such that its horizontal range is equal to 3 times its maximum height. So we want to look for a scenario in which the range will be 3 times maximum height. At what angle should he fire to achieve this? Okay, so we are looking for theta. Theta is unknown. Okay, I'll probably just use formula method. solve this because it's going to be easier. So the formula for range is u square sine 2 theta over g. The maximum height is u square sine square theta over 2g. Since range must equal to 3 times height, it then means that u square sine 2 theta over g must equal to 3 times u square sine square theta over 2g. Then if I FOIL this bracket, I'm going to get u square sine 2 theta over g is equal to 3 u square sine square theta over 2g. So u square can cancel u square, g can cancel g. Now I'm left with sine 2 theta is equal to 3 sine square theta over 2. As earlier mentioned when we are doing the derivation for this formula, we said that sine 2 theta from trigonometry identity is equal to 2 sine theta multiplied by cos theta. Then sine square theta, as I said before, is sine theta multiplied by sine theta. That's the meaning of sine square theta. That is, you find sine theta, then you square it. That means all over 2. So one of these can cancel one of these. Then I'm left with 2 cos theta equals to 3 sine theta over 2. What I can do is to divide both sides by cos theta. So divide this by cos theta, divide this by 1 over, or multiply by 1 over cos theta, still the same thing. So this cancel this. I'm going to have 2 equals 3 over 2 multiplied by sine theta over cos theta. And you probably know that sine theta over cos theta is equal to tan theta. So we have 2 equals to 3 over 2 multiplied by tan theta. Since we are looking for angle, the first thing I will do is I'll multiply both sides by 2 over 3 times 2 over 3 so that I can eliminate this. So on the left hand side, I will then get 4 over 3 is equal to tan theta. That means tan theta equals 4 over 3 is equal to 1.333. Then theta is going to equal to tan inverse or arctan 1.333. And if you plug that in your calculator, you should get 53.13 degrees. Make sure that your calculator is in degree mode. If you put it in radian, you're not going to get this. So it means that the angle of projection that must be done for this shooter to get a range which is equal to 3 times the maximum height must be 53 degrees. And the correct answer is going to be an A. Now let's look at our last problem for this video. So this question says that a projectile is fired horizontally from the top of an 80-meter high cliff. So let me picture that. This is a cliff of 80 meters. Distance from this place, this is the ground level, is 80 meters. With a velocity of 40 meters per second. So U is equal to 40 meters per second. Find the horizontal distance traveled before it hits the ground. So we are looking for the range. Range is horizontal distance. So you know that when an object is projected horizontally, the path is going to look like this. Applying range formula in this case will not so much work because you can even see that this object was not projected with an angle. That is why I prefer to solve projectile motion by component. So what do I know? I know that this object is projected with a velocity of 40 meters per second and it was projected horizontally. So when an object is projected horizontally, all the velocity belongs to horizontal components because it was projected horizontally. Or if you think of it this way, since it was projected horizontally and the way we calculate angle of rotation is always to the horizontal, it means that theta is equal to 0 degrees because it wasn't projected with an angle. So if you say that ux is equals to u cos theta, and cos, the angle is 0, so we have u cos 0, and we say that uy is equals to u sin theta, and theta is equal to 0. Since cos 0 is 1, it means that ux is equal to u, and sin 0 is 0, it means that uy is equal to 0. So understand that when an object is projected horizontally, all the velocity belongs to horizontal component. So your ux equals to u, your uy will be equals to 0. You should have that at the back of your mind. So now let me apply this in our problem now. So we have our uy to be equal to 0 because the object was projected horizontally. So uy is 0 meters per second. The unit is very important. And ux is equal to u, which is equal to 40 meters per second. Now we have a height. The height is a vertical height. So it means that this our sy, or better still, let's call it h, is equal to 80 meters, but it's the vertical height. What it means is that we can find the time of flight for this object, that is the time it's going to take to reach the ground, by saying sy equals to uy t plus half gt squared, plus this time because it is coming downward. So sy, which is h, is equal to 80. uy is equal to 0, so 0 times t is 0. So I'm going to leave it that way. Then plus half gt squared, 1 over 2 times, let's take g as 10 times t squared. In fact, take as a rule that when an object is projected horizontally from the top of a height, the height of that tower, or the height of where it is projected from, can be calculated as half gt squared. So you can use this formula. It is correct because if it's projected horizontally, we use s equals to u yt plus half gt squared. When it is projected horizontally, uy is always equal to 0. That means you are left with s, or h, as the case may be, to be half gt squared. So if you are required to find the height of that tower, you can just use half gt squared. So coming back to this question, we now have AD equals to half of 10 is 5, so 5t squared. If I divide 5 by both sides, I'm going to have 16 equals to t squared. Then t will be equals to square root of 16, which is equal to plus or minus 4. And since time cannot be negative, time will be equal to 4 seconds. So I've calculated time. But what I was asked for, in essence, is to calculate range. Remember that I told you that the ideal formula for calculating range is uxt. Right? So this is the formula for calculating range. And we know that our ux is equal to 40, which is the same thing as the velocity in which the object was projected. So now I have 40 multiplied by the time is 4. So 40 times 4 is equal to 160, which means that the range, or the horizontal distance covered by this object, is 160 meters, which makes option D the correct answer. So this is all we have for projectile. Watch out for more practice questions on two-dimensional motion, and watch out for more tutorial video on kinematics. We are still going to cover circular motion, simple harmonic motion, and every other motion in kinematics.